Welcome back, everyone. When last we looked at the project, we had successfully completed the deployment of an AMI on AWS utilizing the Packer tool. The next step for us will be to build out the infrastructure onto which we will host the swarm nodes. This infrastructure will basically be a VPC comprised of 3 networks, 2 private networks, 1 public network. The networks are distributed across 3 availability zones for redundancy. The public network is connected to the internet via an internet gateway. And we'll also take a look possibly at setting up a load balancer in front of the swarm nodes. The swarm cluster will eventually reside in the public network. To execute the build of the infrastructure on AWS, we will be utilizing Terraform. We could also have and did consider CloudFormation, but the idea was to utilize a tool that was more provider agnostic, allowing us the flexibility to possibly utilize Terraform to also deploy components to Azure and GCP. Terraform is a declarative framework that allows us to describe our desired infrastructure via code. For example, here we indicate that we are using AWS as an infrastructure provider. In our swarm file, we have a list of resources. Swarm manager, swarm worker, the count of swarm managers, how many swarm managers do we want, the AMI that we intend to use, which we previously built with Packer, the types of instances we want to use, in our case T2 micro. Terraform has the concept of dependencies, meaning that when you give it the list of items that you intend to build, be it a AWS instance or a VPC component, subnet, security group, very much like a firewall, it will take all those components and build a dependency graph, which will guide its action in creating the components on the cloud provider. So we indicate the subnet that we want the servers to be on, the security groups that go with those servers. We give it information about how to connect to the server once it's up and running. And just as with Packer, we can give it provisioning information, commands to execute once the server is up and running. In this case, we are performing the Docker swarm init commands to create the swarm, and then we have the subsequent Docker swarm join commands, either for joining additional managers or adding swarm workers. So again, we're utilizing Terraform to build out both the AWS infrastructure, the VPC, the subnets, and then we also utilize Terraform to construct the instances that are the swarm cluster nodes. So let's give that a shot. We will now attempt to use Terraform to deploy our Docker swarm. Terraform apply. The initial target will be to create a single swarm manager. We'll be doing a swarm init. Our initial manager count is 1. So as you can see in our swarm manager resource, count will be 1, and we test for swarm init. If we are in fact doing a swarm init, then we will execute docker swarm init. We will also add a docker label to be used later. Okay, swarm init. No errors reported. 11 objects to be added. Those include the VPC, various subnets, an internet gateway, our security group, and the swarm manager itself. Is everything good? Yes. Building out the various components within AWS. So if we were to revisit the console, we see that our VPC project VPC has been constructed. We have subnets. We have an internet gateway. And we have a swarm manager that is being constructed. And our build is complete. Let's attempt to connect to Swarm Manager 1. We'll provide it with the SSH key, and we can use the IP address that has been reported back to us. We need to provide the correct username, Ubuntu at, and we are connected. And if you recall, we, in our Packer build, had requested that Docker be installed. So on this Swarm Manager, if we run Docker, Docker is installed. When the swarm was created, we did a Docker swarm init. So if we were to docker node ls, you can see that we have a 1 node swarm. Now that the swarm build has been completed, we have other variables that have been set, which include the default number of swarm managers, 2, the default number of swarm workers, 2, So if we were to run Terraform apply, Terraform will compare what has been previously built with what is now being requested to be built. During the initial build, we had specified that we simply wanted a single swarm manager. Now our intention is to build all the components, and all the components would include 2 swarm managers and 2 swarm workers. We're also not doing a swarm init, so therefore, if not swarm init, then we'll be doing a swarm join. So the new swarm manager ought to join the existing swarm, and so will the new swarm workers. One additional step that we will have to do is the retrieval of the tokens. So let's break that, and we will execute swarm get tokens. And if we were to check our env, we see that the swarm tokens have been retrieved. They're in the environment and are now usable by Terraform. So if we now run Terraform again with apply, there are 13 new objects to add. So there are additional subnets, and there are swarm workers. So we will say yes. Now I do have multiple files here, some of which are scripts, some of which are .tf, Terraform files. FYI, all these TF components could be included into one single large config file, but for easier maintainability, I've broken them out into separate files. And I also have multiple shell scripts which we execute with various commands. These can, of course, all be fully automated, but have been made into separate steps for us to follow along during this exercise. Okay, the build is complete. If we revisit the Swarm Manager 1 node and perform docker node ls, we now see that there are 4 members in our swarm, 2 managers and 2 workers. And if we revisit AWS and do a refresh, we see that we now have 4 running swarm nodes. Okay, so the next step will be for us to take a look at deploying a service onto the Docker swarm. See you in the next video.